It also came in the same plane as the planets around the sun, within 5 degrees, and the chance for that happening at random is 1 in 500. It may release some other objects that reach the planets, and it will continue along its course.
Alarm bells are ringing across the astronomical community. The interstellar object 3 I/ATLAS, a visitor from another star system, has abruptly and inexplicably shifted its trajectory. Instead of a distant flyby, it is now heading straight for Mars. This sudden turn has left Harvard astronomers, among others, completely baffled, struggling to reconcile the new data with established scientific models. The thing nobody tells you is just how rare, how truly impossible, such an unpredicted maneuver is for a natural object of this kind. We're talking about something moving faster than anything we've ever tracked. A cosmic U-turn. The universe, vast and indifferent, rarely offers up such a raw, undeniable shock, yet that's precisely what happened when the interstellar object 3 I/ATLAS, a rogue comet from beyond our sun's reach, executed what can only be described as an impossible U-turn. Just a few weeks ago, experts worldwide, including the revered astronomers at Harvard University, were tracking 3 I/ATLAS on a predictable, if unusual, hyperbolic trajectory, a path that would see it skim past our inner solar system and then vanish back into the endless black. But not all things are what they seem, and this cosmic wanderer had a secret agenda. The data started trickling in, subtle at first, then undeniable. What was once a clear, outbound trajectory shifted. The object, initially slated for a distant passage, began curving inward. Not just a slight correction, but a dramatic pivot, placing it squarely on a path that intersects with Mars. To put it mildly, the astronomical community was sent into a frenzy. Imagine watching a rock thrown across a football field, only for it to suddenly, mid-air, change its target to hit a specific spot on the 50-yard line. That's the scale of the surprise 3 IATLAS delivered. For months, many people were crazy about following this third known interstellar visitor. Its initial speed alone was a wow factor. It was hurtling through space at an astonishing speed of roughly 130,000 miles per hour relative to the sun, far faster than the previous two interstellar guests, Oumuamua and Borisov. This incredible velocity, nearly 87 kilometers per second, meant it was too fast to be captured by our sun's gravity, making its journey a one-way trip through our stellar neighborhood. Or so everyone thought. The most shocking fact is that natural comets, while known for erratic behavior due to outgassing, typically don't exhibit such precise, sustained directional changes. Their erratic movements are usually small nudges, not a wholesale course alteration. This isn't like a sailboat being pushed by the wind. This is like a sailboat suddenly deploying a powerful engine and changing tack with surgical precision. This is what sent Harvard's leading astronomers, people like Avi Loeb, into a state of heightened alert, prompting intense debate and frantic reevaluations of all models. The initial observations by the Atlas survey telescopes in Chile and Hawaii had correctly identified it as interstellar, marked by its extreme orbital eccentricity of over 6. This number, 6 times higher than Oumuamua's, signifies a trajectory so open it clearly originated from another star system, perhaps billions of years old. Its closest approach to our sun, known as perihelion, is expected around October 30th, 2025, at a distance of about 126 million miles. This places it just inside the orbit of Mars. But the new data shows that on October 3rd, 2025, it will pass within a mere 18 million miles of Mars. That's a hair's breadth in cosmic terms, making it a rendezvous, not just a flyby. What many overlooked is the subtlety in early observations. Some reports hinted at unusual shedding of material, with a comet tail that didn't behave quite right. Dust, when ejected from a comet, usually gets pushed away from the sun by solar radiation pressure. But with 3I Atlas, early data suggested large dust particles, hundreds of microns across, were being ejected towards the sun. This hinted at something more complex than simple ice sublimation. It suggested a core structure or an energy release mechanism, unlike anything seen before. This anomalous behavior, combined with its new course, makes the mystery surrounding 3I/ATLAS grow exponentially. The comet's trajectory is tightening, its speed is shifting, and for the first time, the numbers suggest a possible direct collision with the red planet. Its tail doesn't behave like a normal comet. It pulses every 17 minutes, releasing bursts of gas with clockwork precision, almost steering itself like a spacecraft. Spectroscopy results, some leaked, hint at metallic cores and unnatural glints in Mars orbit, sparking fears. You can see this everywhere in the hushed conversations among scientists, the question of whether this is a natural phenomenon or something else entirely. The implications are staggering, pushing the boundaries of what we thought was possible in celestial mechanics. The scientific community is now not just observing a comet, they are witnessing a cosmic event that could rewrite our understanding of interstellar objects. This dramatic shift forces us to ask, what secrets does this mysterious traveler hold as it speeds towards Mars? The interstellar lineup. Before the shocking course correction, 3I/ATLAS was already a celebrity in the astronomical world, marking only the third time humanity had definitively observed an object from another star system passing through our own. The first, Oumuamua, in 2017, was a perplexing cigar-shaped enigma, lacking a visible coma or tail. Many people were crazy about the idea it could be an alien probe due to its unusual shape and unexpected acceleration. Then came Borisov in 2019, a more conventional-looking comet, though undeniably interstellar. 3I/ATLAS, discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in July 2025, immediately stood out. The thing nobody tells you is how incredibly rare these encounters are, or at least how rare they were thought to be. For eons, countless objects have likely traversed the vastness between stars, yet only 3 have been confirmed. This suggests our galaxy is teeming with such interstellar vagabonds, each a tiny time capsule from a distant stellar nursery. 3I/ATLAS, with its robust cometary activity and estimated size, is by far the largest and brightest of the 3, making it an unprecedented opportunity for study. Initial estimates put its diameter anywhere from 1,444 feet to 3.5 miles across, with some wilder estimates going up to 12 miles. Imagine an object potentially the size of a small city barreling through space, carrying material from a star system light years away. What many overlooked in the early days was that 3I Atlas displayed an exceptionally carbon dioxide-rich coma and a peculiar composition with nickel, but very little iron. These subtle clues were initially attributed to unusual cometary processes, but now, in light of its trajectory shift, they take on a whole new meaning. Could these compositional oddities be related to its ability to alter its path? The most shocking fact is that even before the dramatic course change, some researchers like Avi Loeb had floated the idea that Oumuamua's strange acceleration might have been due to it being an artificial light sail. These kinds of theories, once dismissed as fringe, are now being revisited with a chilling new seriousness, you see. The journey of 3I Atlas began billions of years ago, ejected from its home star system, drifting through interstellar space for untold millennia before accidentally stumbling into our solar system. The sheer scale of this journey, a lonely voyage through the cosmic dark, is a wow factor in itself. It's like an aeon-old fridge, as one scientist put it, now opening to release its ancient contents. Its passage offers a unique glimpse into the building blocks of other star systems, potentially even offering clues about the astrobiological implications of planet formation elsewhere. This isn't just a space rock, it's a message in a bottle from the past. But as its path narrows towards Mars, the questions multiply faster than answers, challenging our basic understanding of cometary behavior and indeed interstellar visitors. A puzzling pulse. The scientific community, particularly the brilliant minds at Harvard and NASA's Jet Propulsion Laboratory, now find themselves in an unprecedented predicament. They have a celestial object, 3I/ATLAS, behaving in ways that defy conventional astrophysics. What many overlooked is that predicting comet behavior is already complex, with outgassing from ice-creating subtle non-gravitational forces. But the sudden sustained course correction witnessed with 3 IATLAS is on a wholly different magnitude. This isn't just a small correction, this is a deliberate-looking change of direction. The thing nobody tells you is that even the most advanced computer models struggle to account for such a sharp, directed alteration in trajectory for an object of this size and speed. For months, it was assumed its course was dictated solely by gravity, a predictable dance around the sun. But the new data forces a re-evaluation of everything. Some hypotheses being whispered in hushed tones include the possibility of a highly anisotropic outgassing, where material is expelled with extreme force in a very specific direction, acting like a tiny rocket engine. This would require an internal structure and a volatile composition far beyond anything we've observed in natural comets. But not all things are what they seem, and this theory, while plausible for minor adjustments, strains credibility for such a dramatic turn. This brings us to another wow factor, the reported pulsing tail. Unlike a steady stream of gas and dust, some observations indicate 3I Atlas is releasing material in rhythmic bursts, approximately every 17 minutes. This isn't random, it's almost too precise, too ordered for a typical comet. This clockwork precision, if confirmed, is a truly astonishing detail that fuels the more exotic interpretations. You can see this everywhere, from specialist forums to cautious scientific papers, that this pulsing behavior is a major head-scratcher. The most shocking fact is that spectroscopy has revealed unusual metallic components within the comet's coma, combined with signals that some interpret as highly structured. While the scientific consensus still leans towards a natural explanation, the sheer number of anomalies, the extreme eccentricity, the unusual composition, the non-gravitational acceleration, and now the pulsing tail are accumulating. Each anomaly by itself might be explained away, but together they form a truly perplexing picture. Avi Loeb, the controversial Harvard astronomer, has famously championed the idea that some interstellar objects might be technosignatures, signs of alien technology. His arguments, once largely ignored, are gaining new traction, you see. He suggests that the observed changes could be consistent with controlled movement, as if something or someone is piloting this object. While extreme, the unprecedented behavior of 3 IATLAS forces even the most skeptical to consider broader possibilities. The statistical improbability of its perfect alignment with the ecliptic plane, for instance, is another wow factor that makes some scientists pause. As 3I/ATLAS closes in on Mars, the pressure on scientists to understand this cosmic outlier grows, and the answers may force us to rethink our place in the universe. Red planet at risk. The dramatic shift of 3I/ATLAS's trajectory places Mars directly in its path for an incredibly close approach, far closer and more alarmingly intimate than any initial model had predicted. On October 3, 2025, this interstellar visitor will hurtle past the red planet at a staggering velocity, closing to a distance of only 18 million miles. To put it mildly, this is an astronomical eyelash flutter away. In the vast empty scales of the solar system, this is akin to a bullet grazing a cheek. While not a direct impact, such a close encounter with an object potentially miles wide, moving at extraordinary speeds, carries significant implications and risks, fundamentally changing the game for planetary defense. It forces us to confront a new class of threat: high-speed intruders from the interstellar void, whose paths are far less predictable than our local asteroid population. What many in the public overlooked, and what mission planners are now frantically focused on, is the sheer density of human-made objects currently orbiting Mars. The red planet is not a desolate outpost. It is a bustling hub of scientific exploration, a celestial beacon attended by a fleet of sophisticated orbiters from NASA, the European Space Agency, and other national programs. These invaluable assets include NASA's Mars Reconnaissance Orbiter with its powerful high-rise camera, ESA's venerable Mars Express, and the keen-eyed ExoMars Trace Gas Orbiter. The thing nobody tells you is that this orbital infrastructure makes Mars the most intensely and continuously observed planet in our solar system, aside from our own Earth. These spacecraft, designed and dispatched for the long-term study of Martian geology and atmosphere, now find themselves in a unique, serendipitous position. They are our frontline observatories for an object from another star. This close pass offers an unprecedented scientific opportunity, a true wow factor that has astronomers and planetary scientists buzzing with anticipation. For the very first time, humanity has a chance to image the nucleus and coma of an interstellar object with resolutions that are utterly beyond the reach of even our most powerful Earth-based or deep space telescopes like Hubble or Webb. The proximity is everything. NASA's high-rise camera, for example, is powerful enough to distinguish features as small as 10 inches on the Martian surface from its orbit. When aimed at 3I/ATLAS, it could provide images sharp enough to separate the comet's solid core from its incandescent, outgassing cloud of dust and gas. These images could reveal secrets about its true size, its shape, whether it's a single body or a collection of fragments, and perhaps even its surface features, like craters or fissures. This could finally confirm the tantalizing but unproven theories about its supposed metallic core and strange compositional makeup. The most shocking fact, however, lies not in the opportunity, but in the potential risk. An 18 million mile miss might sound safe, but at these velocities, the danger zone is far larger than the object itself. 3I/ATLAS is an active comet, actively shedding a river of material, a trail of dust, ice crystals, and pebbles as it is warmed by the sun. If these particles, even microscopic ones, were to intersect with the high-speed paths of Mars's satellites, the results could be catastrophic. Imagine a tiny grain of sand weighing less than a gram, hitting a satellite at tens of thousands of miles per hour. Due to the physics of kinetic energy, that impact would be equivalent to a grenade detonation. The damage could be significant, you see, potentially crippling or destroying a billion-dollar scientific instrument. The space agencies are already developing and executing complex contingency plans, meticulously adjusting the orbits of their precious Martian assets to minimize any potential exposure to the densest parts of the debris trail. This is truly a first-of-its-kind event, a high-stakes celestial ballet demanding rapid, coordinated international action. Beyond the immediate risk and the observational reward, the flyby of 3I/ATLAS past Mars could provide data that speaks to one of the most profound questions we can ask. It could help reveal if this object is truly a natural wanderer or if something more astonishing is at play. The European Space Agency's orbiters, equipped with sensitive spectrometers, will analyze the light coming from the comet's coma, breaking it down to read its chemical fingerprint. Could this object be a primitive relic from the early universe, carrying untouched material from the protoplanetary disk of another star? Or will its behavior, its trajectory, and its composition hint at something more engineered? This encounter, set against the backdrop of the red Martian landscape, will bring new data, new puzzles, and perhaps answers that change everything we thought we knew about our place in the cosmos. The Cosmic Reckoning. The journey of 3I/ATLAS past Mars is far more than a scientific curiosity. It's a moment of profound cosmic introspection that has ignited a firestorm of debate in laboratories and late-night forums alike. We've seen the astounding data, the impossible non-gravitational accelerations, and the puzzling spectrographic compositions. But not all things are what they seem, and a growing number of people are captivated by the possibility that this visitor from another star holds secrets far grander than those of a mere comet. The thing nobody tells you in the official press releases is how much genuine apprehension and hushed, wide-eyed wonder exists behind the veneer of scientific excitement. Could it be, as daring thinkers like Harvard's Avi Loeb have persistently suggested about interstellar objects, a vessel, a relic of an ancient, long-vanished civilization drifting silently through the void, perhaps performing observational maneuvers as it passes through our solar system? The idea might sound like the stuff of pulp science fiction, but the unprecedented behavior of 3I/ATLAS compels us to consider even the most unconventional explanations. The rhythmically pulsing tail, the precise and sustained course correction as it neared the Martian gravity well, the unusual lack of expected water ice signatures. These aren't just anomalies, they're data points that stubbornly refuse to fit into our standard planetary science textbooks. What many overlooked in their hurried attempts to classify this object is the cumulative weight of these oddities. A single anomaly can be dismissed as a fluke, two can be a coincidence, but three or more begin to paint a portrait of something else entirely. While a natural explanation remains the default for the majority of the scientific community, the audacious trajectory of 3 I/ATLAS forces a critical, perhaps uncomfortable examination of that assumption. If this object is truly natural, then our understanding of cometary mechanics and interstellar object interactions is far more incomplete than we ever realized. If it isn't, if its movements are indeed controlled or a product of technology, then the implications are truly mind-bending, marking a pivotal moment in the entire history of human consciousness. This opens the door to theories that venture far beyond a simple derelict craft. Some speculate it could be an active Bracewell probe, a sophisticated autonomous messenger designed to seek out and make contact with emerging technological civilizations. Its course alteration near Mars might not have been a random outgassing event, but a deliberate maneuver to get a better look, or perhaps to use the planet's gravity to adjust its course towards its next star system of interest. Others have posited it could be a cosmic seed, a terraforming device whose unique composition is a payload designed to alter planetary atmospheres, with its path through our system being just one stop on a million-year mission. Venturing deeper into the theoretical abyss, what if it's not a ship, but a shard? A fragment of a colossal alien megastructure, like a Dyson sphere or a stellar engine, shattered in some unimaginable cataclysm eons ago. This could explain the strange metallic composition and its resilience to the sun's heat. The wildest theory, whispered on the fringes of academia, suggests it might not be technological at all, but biological, a form of silicon-based spacefaring life, a cosmic leviathan whose pulsing tail is a form of metabolic exhaust and whose maneuvers are instinctual reactions to gravitational fields. The most shocking fact is how little we still truly know about the cosmos, despite our advanced instruments and brilliant minds. 3 I/ATLAS serves as a stark, humbling reminder of the universe's boundless capacity for wonder and the unexpected. As the Mars orbiters and Deep Space Network antennas gather their invaluable data, scientists will pore over every single byte, searching for patterns, for answers, for anything that can unlock the true nature of this mysterious wanderer. This isn't about an immediate threat to Earth. The calculations show it will remain a ghost in our night sky, passing approximately 168 million miles from our planet in December 2025. Instead, it's about knowledge, about the fundamental soul-shaking questions of our existence. Are we alone? You can see this everywhere. The universe is constantly challenging our perceptions, expanding our understanding. The speculation around 3 I/ATLAS, while thrilling, must be grounded in the data. For now, it officially remains a natural comet, albeit one that is incredibly active and unusually composed. The precise course changes might be extreme outgassing from specific highly volatile regions of nitrogen ice. These natural explanations, while stretched to their limits, are still the most probable. Yet the persistent anomalies leave a lingering question, a tiny crack in the edifice of our certainties. This object teaches us that even when we think we have all the pieces, the universe can always surprise us. Always. This baffling interstellar visitor has certainly left us with more questions than answers. What do you think 3 IATLAS truly is? Is it just a comet or something more? Let us know below. And if you found this exploration of the cosmos intriguing, remember to like and subscribe for more deep dives into the universe's biggest puzzles.